Hi class, I'm here to talk about problem 84 and then next video perhaps yeah, I'm just gonna split in another video for 88 and I'm gonna be finishing all the problems for chapter 6. I do hope that all these videos have been helping you. The reason why I assign so many problems is to make sure that you understand what's going on. And really, a lot of these problems, like this, for example, don't really take you a lot of time. It's just I need to make sure that you understand what's going on. Just throwing the problems on you and without explanation without showing you what's going on, it's not going to make any sense. Then when it comes to your midterm and I put a problem like this, uh, and if you really don't understand what happened, it's not going to be the same numbers and then you would be lost. Okay, so that's why I'm giving you all these details. Just a quick thing about problem 74. Last night I calculated everything for you and then I said the letter D. Even though I was looking at the values, I kept saying the range was between 90 and 100, but it's actually I typed it correctly. I just said it wrong. The range is between 90 and 110. The 50%, so 68% right here. So 50% would be about between 90 and 110 your range. So let's go to 84. I did put our bell curve with all the percentages and I purposely included the 4 so you can see exactly what I'm talking about. Right here, those are just the values that is giving the problem and the reason why I show 0 because I haven't put any information here yet. So let's start with the problem and hopefully it will make sense. Right here is talking about a lawsuit about a pregnancy that they are trying to determine whether this man is the father or not. So right here says that the length of a pregnancy in general is normally distributed. So it's talking about our curve with a mean of 280 days right here. The reason why you see all this is because I already put the formulas. So when I put the values here, it's going to calculate for me one standard deviation above the mean, which is the mean plus one, and then two standard deviations, which is the mean plus two times the standard deviation. Okay, so it's going to change now. And then I standard deviation of 13 days. Here we go. Now I have all your values. I did that before, so it wouldn't take too long. Right here we are talking about, we are assuming the whole population. I'm not talking about a sample. Okay, so here's my mu, my sigma, and here's my to find my z-score, and also if I had to find my x value based on my z-score, if they were giving me the other way around, I still would be using the same formula. I hope that is clear by now. I'm gonna get rid of the z right here because we're really gonna have to find two z values and why. Well, let's keep reading. This father, the one that is supposedly father, he was out of the country from 240 to 306 days before the child was born. Again, this father, this person that they're saying could be the father, all the way from about here, which is a little higher than a minus. Do you see 241? So 240 would be about here. So a little less than minus, actually in this case higher, but in a negative side, three standard deviations, all the way to exactly two standard deviation, 306. Do you see the values? 240, which is 241 exact, to 306. So all this area right here, this person who could um, possibly be the father, he was out of the country. So there's no way that all this percentage here, he could be the father. And this is exactly what he's asking us. We're going to calculate the probability that he's not the father. So the probability that he's not the father, it's all this right here. But the probability that he could be the father would be everything else. So if he was out from here to here, so these two values here, yes, he could be the father. And then this value here, and then a little more from the 3, not the whole, but I'm going to mark both. So about this, he actually no, because it goes from 3. Here includes 3 and 4. Here is just this little portion right here, okay? So this is the so you should just by looking at this curve, I haven't even calculated my z-scores or nothing. Okay, so if someone just give me this and they provide me the percentages, of course, and they ask you, what do you think? Do you think that the probability that he was not, let's say, if they ask you, what is if you think the probability that he could be the father is high, well, just by looking here and knowing that he was out all this time right here, we're gonna see it's very small. And you could answer, oh yeah, it's very small. And we could go even further and say, you know what? If they say that three standard deviations from 2 to 3 is about a 2.14%, not 20, so is a 214, and then from 3 to 4 is a point, it's a point 13. So really, we would say that this region here is only 2.27% chance. And over here, it's from, it says 240, which is a little bit less. So let's just deduct a little bit from 0.13. And let's say that instead of 0.13, because it's not 240, it's 240, not 241. So, okay, let's say this would be about a 11%, or yeah, or even a 10%. Well, let's just leave it at 11. That's fine. 0.11%, okay? That's not 11%. Okay, so without even calculating my z-scores, if I would add the 2% that he was out of the country, I mean that he was in the country, that would be only a 2.38%. So when you calculate here, the probability that he is the father, it should be something like this little, this small. Okay, well, I'm gonna leave it right here so it doesn't confuse you. So if I'm telling you that this portion right here, these two little ends, is the probability that he is the father. So everything else, and is a curve that is 100%, is the probability that he's not, because he was out of the country. Therefore, it would be a 1 for 100% minus your 2.38. So would say that right here you should expect to find actually the other way around. Let me put it like this so you can see. So the probability that he's not the father, you should find when calculating your z-scores about this value, and the probability that he is the father, you should find a very small amount right here. If we don't find anything like looks like this, then I'm sure we are incorrect, or I'm incorrect. Let's continue. Um, right here it says, so the pregnancy would have been less than 204 days, less than 204 days, 40 days, sorry, or more than 306 days, or more than 306 days. Okay, so the child was born, everything is great. So now he's asking, what's the probability that he was not the father, and what's the probability that he could be the father? So right here, I'm asking for these two probabilities right here. And then it tells you to calculate the z-scores first, and then to give me the probability. So pretty much you're saying, let's find the z-score and then give me the percentage. Okay, the equivalent. So here we go. This is our formula. We do have the x value right here. We do have the mean, and we do have the standard deviation. Great. So let's start. we're gonna do the 240 is my x right here, right? Minus my mean divided by my standard deviation. Okay. See how it says minus 3.08? So we know it's on the minus side 3. And remember I said it should be a little more than point minus 3 because 240, not 241. There you go. And here I should expect have a value of 2 standard deviations because 306 is right on 2. So if I don't find 2 here, something's probably wrong. So let's go and do equals to the 306 for my x. Now I'm doing the other tip of my curve minus my mean divided by my standard deviation. There we go. Bingo. 2. Okay, so far we're on the right track. Perfect. So now let's see if we keep on that track. So remember I said without even calculating my scores, I would get about this. And then right here I confirm my z-scores. They should be about this. Then now that we have the z-scores, we have to look at our z-table. Okay, so first it's telling me that the probability of x being less than 240 is minus 308. So let's look at minus 308. And remember that this table right here, it just gives me uh, anything to like this. Oh, well, right here is just showing me this little percentage right here. But it really, this table is showing me anything from z and the rest of the curve. So minus 308, we're going to find minus 3.0 and then 08. Remember, we're not adding. Oh. There we go. That's about 10%. Can you see over here? Remember, these are percentages. Minus 308. And if we would put in more digits, which is not necessary, I just want to show you that you could either go by 11 or 10%. Oh, look at this. Doesn't it look similar? But I'm gonna go by the table and I'm gonna respect the digits. So I'm actually gonna use 0.0010. Okay, so this percentage right here, I'll say is a 0.0010 point, not 10%. And now we're gonna find our probability for 2.0. So we're going to the positive side. However, remember this part here shows you everything from this z value down, correct? So down, not up. So you should find actually a very high amount because I'm gonna show everything from this two standard deviations all the way to the end. So if you add all this up, you know this is already 95% right here. Remember, 68% for one standard deviation, then 95.44% for two standard deviations, and then you're still gonna end at the end. So you should find something about, let me see, 95, 97, almost 98%. And if you don't, again, we're incorrect. So at 2.0, let's go. Here we go. There we go. 0.9772. So 2.00, right? It's about a 98%. That's what I just referred to here. That just by looking here, if you would add all these percentages, you would find about um, a 98%. And look at this right here. And you're seeing 97.62, but we're not done yet. Okay, and let me show you why. So 90, let's put it over here so it makes more sense. 0.9772, right? And then you said, oh yeah, it's about right. Well, actually, it's gonna get even more correct because think about it. If I just calculated two standard deviation all the way down, well, I have to eliminate this little tip right here because this part here, he was in the country. So I must eliminate that. So I would do equals to my all these values right here minus my 10% over here. Bingo. Look at that. Actually, it's quite exciting for me. Sorry. When you get a perfect amount without even calculating your z-scores. Um, and therefore, okay, so if you know now, you already have the answer actually for the part that he's not the father. Why? Because remember, all this portion right here, eliminating this and this, is the part he was out of the country, therefore he couldn't possibly be the father. Well, if 97.62% is the portion that he couldn't possibly be the father, then you know that 100% for the whole curve minus the 97.62, and there we go. And then without even looking at the z-scores, you could approximately, but that takes time for you to look at this and get used to the values. So go ahead and perform your calculations. And if you do look at all this and does not make any sense, please email me. Remember, you are welcome to send me your homework in advance for feedback. I just need enough time to give you feedback. So if you send me that on Sunday, most likely I won't have much time to provide you feedback if everybody would decide to email me on a Sunday. And I do try to get back to everyone the fast as I can. And I'm gonna complete this video, finish this video because I'm at 16 minutes or about 17. And then I'm gonna record 88. And then now you're only gonna have videos from me next week, either late Tuesday or Wednesday, most like Wednesday. And then we're gonna start reviewing things for your midterm as well. Okay, thank you.